Okay, welcome to Derivatives Lesson 1. Now, derivatives is a very important topic in calculus. As a matter of fact, the first quarter of calculus is basically spent on derivatives. Then when you get to BC, you do more derivatives. So derivatives is a huge topic in calculus. And in this video, what we're going to do is use the formal definition of derivative to find the derivative of a function. And then we're also going to look at sketching the derivative of a function. There are two definitions I want you to be familiar with, and one is the secant line. Now, the secant line represents the average rate of change of a particle over time or over some interval. Now, if you look at the formula for the average rate of change, f of b minus f of a over b minus a, that should remind you of something. So if you recall from Math 1 that the average rate of change is simply the slope, and we use the same symbol, it's simply the slope. So the way that you're used to seeing this is simply y2 minus y1 over x2 minus x1. Well, this is exactly the same thing. So instead of calling this x, we're calling this a, and we're calling this b. So f of b is y2, and f of a is y1, and a, of course, is x1, b is x2. So it's the exact same formula that you learned in slope. We're just using it in a more calculus way. Now, if we want to see what's going on at an instant, so the average rate of change is how things are changing over time. So if I want to know how tall someone grew over a year, that would be the average rate of change. But if I want to know how fast that person is growing at this instant, that would give me a tangent line, or the slope for the tangent line. So the slope of the tangent line tells us what's happening at an instant. And you can see that from this graphics. So whereas if we were to do the average rate of change of this, we would maybe take 2 points, and we would find the average rate of change. But if I want to know what's going on at point A specifically, then I would find the slope of the tangent line. So this little graphic just kind of gives you you can see the difference between the two. The secant line is the average rate of change. The tangent line is the slope at a point. It's an instantaneous slope. How are things changing at any moment? And that is a very important concept in calculus. How are things changing at a second, at a moment? And that we find that with the tangent line. Now, a way that we find the slope is what we call the derivative. So if I want to know how something is changing at an instant, I want to look at the derivative. Now, I'm going to show you today what we call the formal definition of derivatives. It is really the long way of doing it. And then on the next lesson, we're going to look at some rules for finding the derivative, some shortcuts. But today, most teachers will require that you are able to find use the formal definition of derivatives. Most teachers require that. Okay? So this is our formula. Also, I want to talk about notation for a little bit. We read this as f prime of x. That's how this is read, f prime of x, and it indicates derivative. Another way derivative can be written is dy dx. So these two are the two that you see most often in calculus, in a basic calculus class. Here's the big idea with this. Derivative is equal to the slope. The derivative and the slope are synonymous. Slope means how fast something is changing over time. Derivative, how fast something is changing over time. So the derivative and the slope are equal, are the same concept. That's a big idea. You really need to know that. Okay, so what we're going to do is we're going to use the formal definition to find the derivative of this function. So what we know from the previous slide is that f prime of x is equal to f of x plus h minus f of x over h. And I forgot something very important. It's the limit as h approaches 0. That's extremely important, and you have to write that. Okay? So we're going to take the limit as h approaches 0, Now I'm composing this function. Every place I see x in this function, I'm going to replace it with x plus h. So this becomes 3x plus h plus 5 minus the original function. Parentheses here are important, so make sure you put this in parentheses. If you were to write the answer and don't write parentheses, I take off for that. Parentheses are important. So if I were to do a direct substitution, I get 0 over 0. So I have to use some algebra to simplify it. So this gives me the limit as h approaches 0 of 3x plus 3h plus 5 minus 3x minus 5 all over h. Now, I can now simplify this. I notice that the 3x is 0 out, the 5 and the negative 5 0 out. So I am left with the limit as h approaches 0 of 3h over h. And of course, that's still 0 over 0, but what else can I do here? I can cancel out those h's. So I have the limit as h approaches 0 of 3. The limit as h approaches the constant is the constant. So the answer is 3. Now, remember what I said before. Derivative is the same as what? Slope. We know from Algebra 1 that this is in slope-intercept form. So we knew already that the slope was 3. Okay? So I'm just showing you that the slope and the derivative are the same. Okay? Let's try another one. Now, because all the problems won't be as simple as the one that we did before, where I can look at this and say that the slope, the derivative, is 3. All problems are not that simple, so let's do one just a teeny bit more difficult. Again, we're going to use the formal definition of derivatives. So I have f prime of x is equal to the limit as h approaches 0, and every place I see x, I'm going to replace it with h minus the original function all over h. Now, what I like to tell students, you're done with the calculus part. This is the calculus part of that. Now it's simply algebra. And I want you to recall something that we learned in the first unit. I talked about this as a Boldenism to quickly simplify complex fractions, where we can do AD, we multiply these two together, then we multiply these two together, and this sign stays the same. So this sign just comes down. Whatever it is, in this case it's subtraction, it stays the same. And then we're going to have CD, and then we multiply the denominators together, all over BD. Okay? That's just a quick and dirty way to find the least common denominator, and that's what we're going to use here. So we're going to have the limit as h approaches 0. Using that method, I get radical x minus radical x plus h all over radical x plus h times radical x and all over h. Okay? But because this is a complex fraction, I'm multiplying this by the reciprocal, so I'm multiplying times 1 over h. So I'm just going to write this, and I'm not going to show that again. I'm just going to write this as that h going to the denominator. Okay? Now, still, if I do a direct substitution, I still get 0 over 0. Bummer. So what am I going to have to do now? Now I have to rationalize this. This is just getting more and more fun by the minute. So I'm going to rationalize the numerator. And I hope you recall that from last unit, but this becomes radical x plus, the only thing that changes is the sign, and I do that in both the bottom and the top. And if you recall from the previous, the last unit, the middle parts disappear, they zero each other out, so all I have to do is multiply radical x times radical x, which is x, and then minus x, radical x times radical x plus h gives me x plus h without the radical. And then don't try to multiply all this out. You just want to write it as it is because something wonderful happens later. So you just want to keep this in its unsimplified glory. Parentheses are really important, people. I can't stress that enough. Parentheses are important. All righty, let's simplify this bad boy. And we get the limit as h approaches 0. And x minus x, that will zero out, and I'm going to be left with negative h in the top. And then here I have h. We already see that something beautiful is happening. Radical x. And all of this is being multiplied. So everything at the bottom is being multiplied, which means that I can cancel out this h. So now I have the limit as h approaches 0 of negative 1 over radical x plus h times radical x, parenthesis, radical x plus h. You running out of paper yet? Okay, now I'm just going to do a direct substitution and let h equal 0. So when I let h equal 0, this goes to 0. So I end up with radical x times radical x, which is simply negative 1. Radical x times radical x is x. Then I let this h go to 0, so now I have radical x plus radical x, which is 2 rad x. So I can write this as negative 1, 2x rad x. And that is my final answer. Yay! Okay, my suggestion for you is to try this one on your own. So you want to pause the video, and when you come back, I will show you how to do it. Okay? So welcome back. So we're going to start by finding the limit as h approaches 0 of 3x plus h squared plus 2x plus h plus 1 minus the quantity 3x squared plus 2x plus 1 all over h. And the notation for this, I'm not doing the notation, but what I'm finding is f prime of x. So then f prime of x is equal to the limit as h approaches 0. Now, I'm just going to multiply this out. So that's 3x squared plus 2xh plus h squared plus 2, if I distribute that, that'll give me x plus 2h plus 1. And then distributing that negative 1, I get minus 3x squared minus 2x minus 1 all over h. And I can also come in here and distribute this 3, so I get 3x squared plus 6xh plus 3h squared. And all I did was just distribute that, so I can save myself a step. So I have the limit as h approaches 0 of, let's see if we can eliminate anything. The 3x squared, 0 out, because I have a negative and a positive. The 6x, that's actually 6xh. So the 6xh doesn't have a partner, neither does the 3h squared. Okay, that 2x cancels with zeros with that one, so I'm left with plus 2h, and the 1's 0 out, all over h. So factoring out of h, I get the limit as h approaches 0 of h 6x plus 3h plus 2 all over h. And then those h's 0 cancel out, and this goes to 0 because I'm doing a direct substitution. This one will go to 0, and I am left with that f prime of x is equal to 6x plus 2. And that's my final answer. Okay? What I want you to do is I want you to do the next 3 problems. I will reveal the answers in a second, so you do the next 3 problems and then come back and see the answers. There we go. Okay, so I think that's going to do it for video 1. This is just part 1 of lesson 1, so please come back and watch part 2 of lesson 1.